and vice versa for the central bundle of rays where the angle of incidence is less, the focal point is going to be further away. And so that's sort of, rather than a single point focus, it has sort of a range of focal points, essentially. And that is what we mean when we say it gives you depth of field. So if we look at these two scenarios side by side, what you see is in the eye without spherical aberration, you get a very, very well-focused point at the distance of the object that you're looking at. But if you go closer or further away, then it sort of relatively quickly becomes blurry. In the eye with spherical aberration, the central vision, so the point at the distance of the object you're looking at, may be slightly less than in the eye without spherical aberration, but the objects slightly further away and slightly closer are similarly in focus. So that's what we mean by depth of field. There's a in focus objects over a larger range of distances. But the key point here is that the brain is our friend, and it takes those slightly blurrier images and makes them clear. So that's what we mean by taking advantage of spherical aberration. And so how do we use it clinically? Well, that is from measuring it. So we measure it with an aberrometer, we get the wavefront, and mathematically then break it down, reconstruct it with the Zernike polynomial series, which is very useful because the Zernikes are shapes, and these shapes are clinically relevant when we are analysing optics, because there is a shape for sphere, there is a shape for cylinder and axis, and similarly there is a shape for spherical aberration, which is the Z40 coefficient. So in Cresbeyond, obviously we have the minus 1.5 in the non-dominant eye with the depth of field and the plano in the dominant eye, and then you end up with the extended depth of field that sort of gives you that blend zone. Comparison to monovision, where you don't have the depth of field, you need the additional amount of anisometropia to achieve the near vision, but you end up with the gap in between. And so this enables us to achieve the good distance vision and the near vision, as well as the intermediate vision, with the eyes blending, which is why it is tolerant and accepted by a great amount of patients. And so the ablation profile, like I said, is only spherical aberration, so there's no multifocality involved, which means that the topographies all look normal. We're just controlling the amount of spherical aberration that's induced, rather than trying to induce multifocality. Which means that, so if you compare it to corneal LASIK monovision, they're similar. But what we're doing is we're taking those eyes in monovision where there would be too little spherical aberration and moving them into the therapeutic zone. And we're taking those eyes where there'd be too much spherical aberration and bringing it back to the therapeutic zone, so that we get the benefit of depth of field without the symptoms that come from multifocality of quality of vision loss and contrast loss. Thanks very much.